Welcome to our video about dividing by the duplicates. It's sort of a next level kind of permutation question, a little bit tricky. So far, all of our questions have had unique members in the sets, but now we're looking at some sets where there's sort of duplicates. In this case here, we're looking at the three letters APP, and we've got two P's that are identical. So I'm trying to differentiate them with color, but we're going to see that as we create different permutations, the actual outcome is still APP. Or that the outcome is not necessarily unique. So here I can put the A in the middle and P's on the outside. So I've got PAP. And then I can make another arrangement, but it's still the same. The outcome, the visual outcome is not unique at all. And so we can make the arrangements of the letters, like any three letters first, then the second, then two letters for the second position, one for the third. But we can see that there's just only 1, 2, 3 different unique ways to arrange them. So what we have to do is get rid or divide by those duplicates. And in this case, we have 2 P's. So we would divide by the 2 factorial in this case in order to get our 3 ways. Let's take a look at another example. So we've got 3 green markers, 2 blue and 1, or 1 blue and 1 black. How many different ways could we arrange them? And by arranging them, we're really referring to them being uniquely arranged. So in this case here, we can see, oh, look at all the greens are first. Well, what if this one was first? We wouldn't be able to tell the difference. It's not a unique arrangement. Maybe this one's first. It's not unique. So we can start with the 5 factorial, but we want to divide by the 3 factorial because the greens are duplicates of each other. So what does this really look like? We can look at it expanded. So there should be 20 ways that we could arrange these 5 markers uniquely. What if we add another blue in? What does that do now? How do we represent that? Let's get those guys over there. So now we've got 1, 2, 3, 4, 5, 6. We've got the 6 factorial, 6 different ways to show those markers. And we've got the green that are duplicates, and we've got the blue that are duplicates. So, this is, again, where expanding could be helpful in terms of solving this. Of course, you can do it on your calculator, but this is pretty easy here too. So we'll just cross those guys off. And then this whole 3 times 2 times 1 is the same as 6. So all we're left then is with 60. So there's 60 different ways of organizing or arranging those markers. And so lastly, how about the letters in quarantine? Normally you can imagine these as Scrabble tiles. So you've got 10 letters to pick for the first position, 9 for the second, 8 for the third. So again, we're beginning off with our 10 factorial, but we've got a keen eye that says, oh wait, I had duplicates for my A's, and oh look, I've got duplicates for my N's. And so if you had expanded that, I would probably just solve for the 10 factorial in my calculator. So there was originally 3,628,800 ways to arrange the letters, but we'll divide that by 4. So that will give us a mere 907,000 200 ways, unique ways to arrange them.